All right, good evening, everybody. Welcome to McDonald Observatory, our live stream. My name is Stephen Hummel. I'm the dark sky specialist here at McDonald Observatory. And welcome to our live stream of it's really going to be a focus on the constellation of Orion and the many objects within it. And I'm going to be using this telescope here behind me to showcase some of the objects there. And I'm coming to you with an infrared webcam, which is why I look a little bit spooky. It's because this is infrared light. That's why my retinas reflect it really well. But I can't actually see any of this light, which it won't, so that it won't disturb the telescope right behind me. But here at McDonald Observatory, we are known for our very dark skies. We have some of the darkest skies of any major observatory in the world. We're very proud of that title. And it's those dark skies that make programs like this possible. In the region, we have an effort to maintain the skies and keep them that way. You can read more about that on our website, mcdonaldobservatory.org. I'm located in the dome down here at the Visitor Center, the Frankenbash Visitor Center at McDonald Observatory, the little dome with the arrow on it. And Presently, the observatory is closed to the public. We do hope to open as soon as possible, and we will let you know that on our website and in social media via an announcement. But at the moment, we are still closed to the public. But although you can't be here in person to appreciate the sky, this is kind of the next best thing. I'm going to be using this telescope, here pictured in action, tonight. And tonight I'm using a color camera. Sometimes I use a monochrome camera on this program. Sometimes I use a color one. The real difference there is that, well, color cameras, they show color, but they're far less sensitive than a monochrome camera. But tonight we're going to be seeing a lot of very pretty, colorful objects, some real gems of the sky, so it makes sense to use a color camera. However, if you were to look through the telescope with your own eyeball, you would not see color very well, if at all. There's only a few objects where you can really appreciate color in the deep sky, especially really faint things. But a couple of them actually you can see in color, even with the human eye through a telescope tonight. But tonight we have stunning weather. We have just perfect clear skies. We had a few clouds around earlier, but they kindly just mosey on out of here, and they're not going to bother us anymore. Not too cold at 45 degrees Fahrenheit, low humidity, just great conditions all around. So it's going to have great skies for this program. And we are going to, again, talk about the constellation of Orion. That's the real focus tonight. And Orion is perhaps the most recognizable, one of the most famous constellations in the sky. A lot of people ask what my favorite constellation is. It's actually not Orion, it's Scorpius, but it's a really close second for Orion. It really is a standout constellation in the sky. But the myth of Orion goes back to Greek mythology, and Orion is a hunter, and the various stories about him and his journeys and things are kind of vague, and a lot of them conflict each other. But basically, they all agree that he was a hunter. He was quite a skilled hunter, and so the constellation of Orion is usually drawn as him holding either a sword or some weapon above him, and a pelt kind of off to his side of something he's hunted, or sometimes in his other arm, instead of a pelt, it's something like a shield or a bow in some drawings. So this drawing is actually from the 1600s by John Bayer, but in the sky tonight, it is kind of mid level high at the moment, about 30 degrees high in the east or southeast. And if it's dark where you are and you live in North America, then you can likely get a similar view to this if you step outside right now if you're watching this program live. Orion there again in the center, uh, easily one of the most identifiable constellations with the naked eye, even in the city, and a large part due to two bright stars, Betelgeuse, which we're going to look at in the telescope, and Rigel, another very bright star. And Orion, if you can look below him, just along the horizon, there's a bright star called Sirius, which is part of Canis Major. And Canis Major is supposed to be the big dog. It's his hunting dog, There's also Canis Minor, which is another one of his hunting dogs. And just below Orion, to the lower right, is Lepus, which is supposed to be a hare, something he would hunt. And above him, not very visible here, is Taurus the Bull, which he is sort of in combat with in this drawing, this interpretation of the sky. Zooming in a little more, we can kind of see the vague outline of Orion. What it's supposed to look like. And a lot of the constellations, I gotta be honest, they just don't look like the things they're supposed to look like. There's a lot of imagination involved. But Orion, kind of, I can buy it at least. So the most famous pairs are triplet of stars in the sky is, of course, Orion's Belt. Alnitak, Alnilam, and Mintaka are the names of those stars. And the first object we're going to look at tonight is located just off to the right in what's often called Orion's Sword, which is sort of at his side. And what makes this constellation so great from an astronomer's point of view isn't just that it's pretty and it has some history behind it and you can draw pretty pictures out of it. It's that plus there's so much good stuff to see in here. Because within Orion, the bounds of this stick figure we made up in the sky, is the Orion molecular cloud. And the Orion molecular cloud, or sometimes the Orion molecular cloud complex, is a vast area of gas and dust and star-forming regions and very bright, massive stars. So there's going to be a theme tonight of a lot of young, bright stars in star-forming regions because that's really what this region is so famous for, and some of the real highlights of the sky. This image, by the way, that I'm showing right now was taken by Matt Harbison, and he took most of the data for this image from a observatory in Marathon, Texas, which is just south of here a little bit, so also in the Big Bend region of Texas under the same dark skies. And this image is incredibly high resolution. It's a huge mosaic that took him years to complete. So I highly recommend going into the description for this video. You'll see a link. Click the link and you will see the full resolution version of this image. And you can kind of follow along because it's really incredible. But the first object we're going to see in the telescope tonight is the Orion Nebula. It's a bit of an obvious name. It's also known as Messier 42. And that's an easy number to remember, 42, if you're a nerd at least, like I am. But the Orion Nebula is perhaps one of the most famous objects in the entire sky and one of the most photographed. And that's the first thing we're going to look at with the telescope here behind me. And I've already got the telescope trained on it. And so here we go. Here is the live image of the Orion Nebula up close. So wow, this is a live image. Just right away, that should be pretty incredible. It's easily one of the most photogenic objects in the sky, and one of the most colorful as well. It is dominated by red, and if you've tuned into this program, previous programs before, you by now have had it drilled into your brain that red means hydrogen, and it's no different here. Oftentimes when you have very massive stars, like we have here in the center, very bright stars, they excite hydrogen atoms that are around them and make the hydrogen glow in this distinctive red color. So the Orion Nebula is a star-forming region, perhaps the most famous star-forming region in the sky, and one of the easiest to see as well with their own telescope. It is about 1,350 light years away, and that's kind of the same distance from most of the objects. The whole Orion cloud, the broader cloud as a whole, ranges between 1,100 and 1,400 light years away, which is still kind of close compared to some other things we can see in the sky. I mean, it took, in this case, 1,300 or so light years or years for the light to reach us, but compared to most of the other star-forming regions like it, that's still very close. And that's part of the reason why it is so bright. I'm going to get rid of my little view of myself here so that we can just see the nebula a little better. So all of the action going on in the Orion Nebula is really down to the center. these little stars right here at the center. And if I change the settings on the camera a little bit to kind of make it actually a little darker, you'll see that there's these really, really bright stars. They're so bright they're almost oversaturating our view still. And this wonderfully detailed area immediately surrounding it. This is often called the trapezium because the stars trace out a little trapezoid shape. And these stars, their combined light together, as well as the nebula around it, this cloud, are actually bright enough to be seen with the naked eye, even in the city. They are what are they together look like one star, which we call the middle star of Orion's Sword in the constellation. But these four stars are all very young. They're only a few million years old, maybe a couple million or less, which for a star is nothing. You know, our sun is 4.5 billion with a B years old, but these stars are just a few million with an M. So huge order of magnitude difference, and they're all much more massive than the sun. And the more massive the star, the hotter they burn, the more energy they put off. So they're pumping out lots of ultraviolet radiation, which is hitting the surrounding cloud of gas and ionizing it and making it glow red. And some of the light is also reflected a little bit, which adds to kind of that bluish color to it. And when you see this object in a telescope, especially if you have dark skies and a big telescope, then the core of the nebula does have a sort of bluish hue to it. But if you view this object with your own eye through a telescope, you will struggle to see the red, and that's simply because our eyes are not very good at seeing red. They're actually quite pitiful at that particular color, and they're better at seeing blue or green. But it's a wonderfully complex nebula. We're only seeing the brightest portion of it here, but you can kind of begin to see its shape. There's sort of a shelf here, and it's almost a bowl structure. And I have a little animation that shows the structure a little better. Here starting off with infrared data from the Spitzer Space Telescope and other telescopes. And we're kind of flying into the Orion Nebula. And you can see that the big stars, they're kind of nestled down deep in the center. And as we kind of fly in, you begin to realize it is sort of a bowl shape, almost a cavern with one end exposed. But look above the bright stars of the center, and you'll see that there's a little protrusion of gas coming out above them. And if we look back at the live view, we'll see this again. Now that we've seen it in 3D, let's look back at the live view, and you can kind of see that little protrusion sticking out. So it's dark here because the gas and dust is casting a shadow. It's blocking the light from the trapezium stars, and thus it's darker there. So I could honestly talk about this object all night long, but it's not the only star-forming region we're going to look at tonight, because again, Orion is full of star-forming regions. But I do want to zoom back out and show that a wider field view. So not only does the Orion Nebula create that little kind of cavern of glowing gas around it, you'll notice that below it there is an arc of red gas, more hydrogen that's excited. And that arc is called Barnard's Loop, and it is also being, most likely, being excited by the energy from the Orion Nebula. You can kind of see that it's sort of tracing out a little arc around the Orion Nebula, a sort of semicircle. So its effects reach out for many, many light years. But again, one of the most stunning and truly spectacular objects to see in any telescope. Even in binoculars, you can see it. And in this view, we're only seeing the brightest, most interesting part of it, but the whole nebula is actually larger than the full moon in the sky. So it's big, it's bright, and it's not hard to find, which of course makes it a favorite of amateur astronomers. It was actually the first object I ever saw in my own telescope, and the first object I ever photographed through my telescope. I bet for a lot of amateur astronomers, they have a similar story to tell about it. All right, but next we're going to move not too far from there. We are going to move to its neighbor, which is known as the Running Man Nebula. So if we kind of look back here, we just saw the Orion Nebula. Again, this is Matt Harbison's image, and you can go into the description below and see the image in full resolution and kind of follow along if you so choose. But we're going to go to the Running Man Nebula, which is very similar to the Orion Nebula. It's kind of overshadowed. It often doesn't really get much attention, simply because uh, the uh, the Orion Nebula is so much brighter and more famous. But the Running Man Nebula is another star-forming region, very young, massive stars, and it also is kind of got the same color pattern. It's got the bluish color and the red color, and that's what we're going to see here in just a second. So I'm currently loading up that image right now. I've just moved the telescope just a little bit, just to recenter it onto the Running Man Nebula. And I see we have a question here from Bhaskaran, who asks, how can we say live image? Well, the image is coming from the camera attached to this telescope, and it's taking a picture every few seconds and averaging it with the previous pictures. So the data you're seeing from the telescope is being taken as we speak, as we talk right now. So, all right, here is the Running Man Nebula, and we have two little lines there. Isn't that interesting? So the Running Man Nebula, of course, is all the fuzzy stuff around here. These two lines, parallel lines. I'm wondering if anyone in the comments can figure out what that actually is. And you can see they extended a little bit too, as we just combined another exposure. They appeared to get longer. Is anyone sure what that is? Let me know in the comments. I know the answer. I'm just challenging y'all if you can figure that out. But yeah, this is the Running Man Nebula, and you can see we have, again, very bright stars, very massive stars. These stars are maybe 8 or more times the mass of the sun, so they're quite large, and their heat and energy is exciting the cloud around it and making it glow. And we can see a little hint of red in there as well. And yeah, see, some people guess correctly. They're satellites, but they're not just any satellites. These are geostationary satellites. And what's actually really going on is that the telescope is moving and to follow the stars, and the satellites are mostly staying still. Because right here, right in this particular part of the sky, is called the Geostationary Belt, where you've got all these satellites that are in such a particular orbit that they circle the Earth at the same rate that the Earth spins. So from our perspective on the ground, they don't appear to move. So really, if I were to turn the tracking on the telescope off, we would see that those lines would just become little dots, and all the stars would be trailed, because really it's the Earth spinning. But yeah, all those satellites, all those kinds of satellites are kind of in this particular line in the sky. So right here, just by chance, from our location, the McDonald Observatory, at this time, we see the geostationary satellites there more frequently, kind of running through the Running Man Orion Nebula area. But anyway, a little annoying, but not a big deal. But I don't know if y'all see the Running Man shape. Obviously, it's called that because you can kind of imagine a man. I've never really seen it as a running man, but I kind of see it as like going kind of like this, It's like his head's over here, and then you got an arm over here, another arm over there, and then some legs. Bit of a stretch, I'll admit, but a lot of these names they're just nicknames. This has many other catalog names, but they're not as fun or easy to remember. But like the Orion Nebula, it's about the same distance. It's really part of the same kind of cloud. In a certain sense, it's almost the same object, but there's sort of a little. It just gets dimmer between them. But if I were to just pan the telescope down a little bit, we would be looking at the Orion Nebula again. But you can definitely see that this star is a little more blue than some of the others. It's subtle, but it's there. Let me stretch the image a little more and kind of adjust the color balance to be more accurate. There we go. It's slightly more accurate. Yeah, but you can see that this star is sort of a whitish blue. That's a clue as to the temperature. And again, the hotter the star, the more blue light it will emit. And the cooler the star, the more yellow or red it will appear. So hot stars are blue, cool stars are red. It's the opposite of your AC or your faucet. Remember that. It's going to come back in a minute. But it is, again, a very massive star. And what you often find in the star-forming regions like this one is that they may be forming hundreds of stars from these clouds, or maybe thousands of stars, but their shape and the colors they emit and really the dynamics of these star-forming regions are driven almost entirely by the top 1% of stars. Those 1%ers, or even less, really. Just a couple of stars can emit so much energy that they dominate or cancel out star formation in the surrounding area. The reddish color is now a little more apparent as I've combined some more exposures, but in this case it's more blue, and that is because these clouds of gas are reflecting light. And like before, we can see that there is a shadow. So what we're really seeing here is a denser clump of gas, right? And what this gas is for the most part hydrogen, because it is the most abundant element in the universe. But we're also seeing things like molecules, even sugars sometimes, forming within these dense clouds. And this is where you expect star formation. When clouds of gas come together, gravity begins to take over. They eventually collapse down on themselves, and when the pressures and temperatures reach a certain threshold for fusion to start at the center, a star is born. But in order for that to really start, you have to have the gas come together close enough in the first place. And either that happens because it's very cold and still, and things just slowly clump together over time, or something kind of pushes and sweeps the gas together, which may heat it up too much in the process, but sometimes the conditions are just right. And we have a little of both in the Orion Nebula in this one. The big stars, they're really newly formed, but they've canceled star formation immediately around them. But in those darker areas where we don't really see, that's where new stars are being born. So, all right, these are new baby stars, all a few million years old or so. We're going to take a look now at the, well, I just forgot the name. Oh, Betelgeuse, one of the most famous stars in the sky as well. So we'll go back to our Orion Nebula here, wide field view. And you can see over on the left is Betelgeuse, and that is how you spell it. I'm only going to say that name twice, so now I can't say it anymore. I'm just kidding. No, you can say Betelgeuse however many times you want. Nothing bad happened to me so far. Maybe it's because I'm spelling it differently. But Betelgeuse, usually in this program, I don't look at individual stars. I have to confess, it's pretty rare for me to look at individual stars. But I'll make an exception for this one. I think for good reason. It's a red supergiant, so you can just tell by the picture its color. And it's also a very, very massive star and very bright. It is among the brightest stars in the sky, but exactly where it ranks depends on when you look at it, because it is also a variable star. It is a star that changes in brightness. And there it is live. There is Betelgeuse. Now, I'll get to those spikes there in the image in just a second. But Betelgeuse is you can tell a lot about a star just by its color. It's kind of this orangey gold, and it again, the color means the temperature. So in this case, we know it can't be as hot as some of the stars we just saw before, but it is very, very bright. It is a star that is sometimes the brightest star in Orion, which gave it the rank of Alpha Orionid or Alpha Orionis in the kind of a rank of the star's brightness, Alpha being the brightest. But it's the other star, Rigel, in Orion, that's actually brighter right now, and it usually is brighter because Betelgeuse, the star here, is a very famously variable star. It's not going to change while we're looking at it, but if we were to, say, graph the curve of its light out over time, we would see it kind of going up and down rather erratically. This data, by the way, comes from the American Association for Variable Star Observers, and this data was mostly contributed to from amateur astronomers, um, who take their own measurements and submit them. And you can see way back down in December 29th, 2019, it reached way down at the bottom, where Betelgeuse emitted about a third or so of as much light as it did at its peak. So a significant dimming. And it made the news, of course. If you paid attention to astronomy news at the beginning of this of 2020, end of 2019, then this was just dominated the news cycle. And then it kind of just faded out. Why? Well, Betelgeuse is a variable star. It's changed in brightness on a routine basis for as long as we've really been observing it. It got a little bit darker last year, though, because not because it was going to explode, as some people will contest, it will eventually, but because instead that there was a cloud of dust around it. And in fact, we do have data resolving Betelgeuse itself. We don't often see stars themselves actually resolved, but Betelgeuse is actually the first star that was ever accomplished with back in 1920, over 100 years ago. But this image from January and December 2019 from the European Southern Observatory shows a distinct dimming in the lower half of the star. And that would be because there was a cloud of dust passing in front of it. And that dust probably was from the star itself. It probably spat out some material because it's a really bizarre star. It's very massive, about 20 times the mass of the sun, and it's running out of fuel. And when massive stars run out of fuel, they become very unstable. They puff up. And in this case, Betelgeuse is puffed up so much that it would swallow our solar system if it replaced the sun, and it doesn't really have a distinct edge, or photosphere as we call it. It kind of just fades out. So it's very big, it's very puffy, so it's not very dense, and oftentimes because it still wants to expand, it lets off material which then cools and coalesces into dust, which then partially obscures the star. And that is why Betelgeuse dimmed. Now, Betelgeuse will go supernova. It will explode, as most massive stars will, especially 8 times the mass of the sun or more. We think Betelgeuse is about 20 times the mass of the sun. But it won't be within our lifetimes. So it'd be really cool. I hope I'm wrong. I hope it does go supernova because it'd be really awesome to see just an enormous explosion, bright point of light, and then everything coming off of it in the sky. But it probably won't. It's just not quite there yet. It probably will take around 100,000 years or so for Betelgeuse to finally explode. And if it does explode within our lifetimes, and I'm wrong, there's nothing to worry about. It will not hurt life on Earth in any noticeable way, and it won't really affect us other than just a nice, pretty view in the sky, which may be so bright you would see it in the daytime even. I hope we get a supernova sometime in our lifetimes. We're kind of overdue. We haven't had good luck with seeing them in the sky, good, really bright ones, in the past century or so. But who knows? It may change, but it's probably not going to be Betelgeuse that causes the explosion. All right, so a lot of people ask about these spikes coming off the star here. And obviously that's not actually part of the star, and you'll see that off of almost any star that I look at that's very bright. And that's due to how the telescope works. If I take a look at the telescope itself, or similar telescopes, you'll see that the telescopes are made from, you have a large mirror at the back. In this case, it's 16 inches across, and that's what gathers the light. So light comes down the tube, hits the primary mirror at the back, and is reflected up to another mirror at the top. And it's that mirror at the top that causes the spikes. You can see that the mirror at the top of the tube is supported by kind of 4 veins. And that structure, those thin little veins, cause that artifact we see in stars called diffraction spikes. The light is bending and interfering with itself. It's actually an interference pattern along those very thin veins, causing the spike. If I were to insert another, like a stick or something, into the path of the telescope, you would see it would gain an additional line, depending on the orientation of the stick I entered. So you can actually tell what kind of a telescope took an image sometimes based on the spikes. This telescope is the same optical design as like the Hubble Space Telescope, and so the Hubble Space Telescope images have the same artifact. Other telescopes don't have veins. They support the secondary mirror a different way, just by sheet of glass or curved piece of glass, so they don't have that effect. Or they don't have a mirror at the top at all, and they work completely differently. And so you get a different pattern or no pattern. But next, we're going to go to another newborn star area in Orion, one of the many, known as M78. And I've never really heard a consistent nickname for this, for Messier 78. I've heard the Casper the Friendly Ghost Nebula before. I think it's kind of a stretch. But I don't know. Maybe y'all can suggest something better for us here in a second. As I load up M78. And I've just moved the telescope. And off we go. So M78 is located also within the Orion molecular cloud. And I don't know why that text is so big. Let me fix that. Get that down there. That's where you belong. I don't know why it reset itself like that. Oh well, I fixed it. Anyway, it's right about there, and it's kind of between Betelgeuse and Alnitak, the lower star on the belt you can see there. And it is much fainter than the Orion Nebula or the Running Man Nebula. So it isn't as frequently photographed, but it still is relatively bright compared to a lot of other nebulae in the sky. And we are almost ready to have our live view of it. I'm just going to do a last few little tweaks before we take a gander at it. And there we go. All right, so here's our live view of Messier 78. And again, feel free to suggest your own nicknames in the comments, what you think it should really be called. But we can see that there are 2 bright stars, not nearly as bright as some of the ones we were looking at earlier. They're still relatively bright, but just a fraction the brightness of Betelgeuse or some of the stars in the Trapezium and the Orion Nebula. But we can see that there is a blue kind of pool here. And actually, let me adjust the colors just a little bit. There we go. Yeah, that's more true color. And so we have almost a pure reflection nebula, in that the dust is reflecting blue light in this case. And reflection nebulae, it's a plural nebula, are generally blue. That's the most common color for them. Because the size of the dust grains in this cloud reflect blue light more than other wavelengths of light, like red. So we don't have a lot of red here, so it tells you that there's not a lot of energy coming off of these stars. Isn't as surprising. This is about the same distance as the other objects we saw, but it's much fainter, so it stands to reason there's a lot less energy coming off of these stars. But there's just enough light that the dust scatters it back to make this reflection nebula. And you can begin to see that there is a dark line kind of over here, almost an arch of denser gas over the nebula. So this is, too, another area of active star formation or recent star formation. These are likely relatively young stars, a few million years old, but not quite as vigorous as some of the other regions. This is kind of more typical region you would see in the sky. And you can see that as the exposure lengthens, you can kind of see there's actually some other areas popping out, too. Let me see if I can make that any brighter. It's a little challenging. We haven't spent very long with the target. But you can begin to see that there is some structure up here and over there as well, some light peeking through. So there is a lot of star formation in the cloud, but it's so recent in this case that it hasn't really blossomed out of the cloud. Those stars in the middle, they're not big enough or they haven't had enough time to push and sweep the gas around them to expose themselves, or they're not exposed enough in our direction to see them. So even though it looks very dark here, there are stars there. You just have a hard time telling because of all the gas obstructing it. But again, this is where you would expect star formation. Large, dark, cool, very cold actually, and sometimes turbulent clouds of gas. That is the recipe for star formation. All right, so Joey Trotz asks, what sort of exposures are we seeing for these images? I've been using 20-second exposures for all of these, stacking them together. For Betelgeuse, that was 5 seconds. I could have gotten way lower, but it's so bright. But for the most part, these are 20-second shots. Um, and Junior CPP asks, where did the dust that forms emission and reflection nebulae come from? It's a good question. The dust, for the most part, has been hanging around since, well, the beginning of the universe or the galaxy. Most of it is just hydrogen, and hydrogen and helium formed shortly after the Big Bang and have been kind of floating around in space and eventually swept together to form something. Some of the gas is recycled, meaning a star died when supernova, like Betelgeuse eventually will do, and the resulting explosion created new elements, heavier elements, which formed dust, which expanded off and eventually got recycled and swept together. So there's a mixture of things that have kind of been there since the beginning of the universe and things that are recycled and part of previous stars that have died and cast their elements off into space. Here is a deeper image of M78 where you can see its structure a little better. You can see that dark band and kind of little another dark band above it on the left, and that bright blue pool. Kind of, I like to think of it as a pool or a lagoon. Just reminds me of like a nice, refreshing, I don't know, pool you'd see at a hotel or something. That's what it reminds me of, but I can't really think of a good nickname for it. So yeah, let me know your nicknames for it. And we'll take one last look at the live view here, and I'm now going to go to the next nebula, another reflection nebula, but with a twist. The next nebula we're going to go to is called the Flame Nebula. So we have nice, cool blue tones here. And next up, we're going to go to kind of a fiery tone. So we just looked at M78, which is on the left. Next up, we're going to the Flame, and then after that, we're going to go to the Horsehead, another very, very famous, well-known nebula in the sky. But the Flame and the Horsehead are both right next to the star Alnitak. And Alnitak is a very bright star, again, one of the stars of Orion's belt, and it is very massive. It's actually one of the most massive and energetic stars in the sky that you can see with the naked eye. It's 1,400 light years away, and yet it's very obvious in the sky. It just goes to show that what we see for the most part in the sky, that's a shot of the Orion Nebula I forgot to show earlier. Very pretty. But what we see for the most part in the sky, the naked eye stars, are not necessarily the closest stars. They're simply almost the whales among the fishes in the sky. They are the giants for the most part that we see. There's a couple exceptions. Sirius is both bright and big and close, but for the most part, what you see in the sky are very, very massive stars that may be very distant. They're just that bright. All right, so next up again is the Flame Nebula, a really stunning and kind of eerie nebula. So yeah, there it is. There's the live view. We've only got one shot in there, so as we begin to combine exposures, we will see it get a little brighter. But there's Alnitak on the lower left. It's so bright, and this is a long exposure, so we have long diffraction spikes coming off of it. some other artifacts too. But really what we're interested in is everything over here. And you can see it looks like a flame. It's kind of got that pattern. Some also have likened it to like a tree or a shrub, this being kind of the trunk and the branches of the tree, and here being the foliage, leaves, except it's red. Maybe it's a dead bush. I don't know. But it's got this really interesting and kind of unique color. It's not common to see in deep sky objects this sort of orange tone. And that's because, well, there's some debate about it, but there's probably two things going on here simultaneously. The first thing is that there is a hidden group of massive or medium-sized stars that are directly behind this black spot. So it's like we have a really thick cloud here blocking our line of sight to a very bright group of stars behind them. And so we're getting kind of the backdrop around it being illuminated. And in this case, those stars are energetic enough not just for the light to be reflected, but to energize and heat up that gas and make it glow red. But in addition to the red color, we also have reflected light from the front, kind of from the foreground, shining on it from Alnitak. And that is kind of muddying the colors a bit and making it kind of appear more yellow overall as opposed to red or blue, which is more common. So yeah, there are not a lot of nebulae that have this tone. It is relatively uncommon, especially on this scale, to have something this kind of big be this obvious. I think it's a really interesting shape as well. I love these details, these sort of ribbons within it of dust and how it obscures. But I really also like to show the view of this same object in the infrared. Because when you use an infrared telescope, you see a whole different assortment of shapes and objects here. So this is the first we'll show the Flame Nebula mirror flipped from this telescope, just a deeper exposure. And here's the same thing from Vista, a telescope in the European Southern Observatory. And you can see it looks very different because in infrared light, those longer infrared colors pass through the dust much better than visible light does. And you can almost see through it. It's almost like having X-ray vision. We do actually have X-ray telescopes, but that's a different thing. But you can kind of see through the heart of that cloud and see that there's actually brighter at the center. So we know that there are stars in there. They're just obscured in the visible wavelength image. And again, let's go back to our live image. And let's see if I can bring out any more details than what we're seeing here. Yeah, it's a wonderful, complex, and I think somewhat eerie-looking nebula. You can also see this with an amateur telescope. Part of the challenge in observing it is Alnitak is just so darn stinking bright that it really kind of gets in the way, and you can see it's kind of getting in the way here. Large telescopes struggle with really bright stars and faint things right next to them. You have to use some special tricks to get around that. This nebula and M78 and basically everything I've shown you again tonight is all roughly the same distance because it's all part of the same cloud. In this case, it's about 1,300 or so light years away. Betelgeuse, however, was about 700 light years away, so it's actually a lot closer. But it's moving through space very rapidly. But it actually probably formed in the kind of the same neighborhood as a lot of the other objects we're seeing tonight. I'm going to try to take another question real fast. About how far apart are the cloud's gas and dust molecules? Would you notice it if you were in one? Asked Tasty Beer 7. I could go for a Tasty Beer. Not really, actually, right now. I'm working. But if you were in the center of this cloud here, you would, if you were just floating in space, the sky would be very dark, and you would notice that for sure. The sky would appear very different. But unless you were right next to or really near a star actively forming, you would mostly pass through it without too much issue, depending on how fast you're going through space. So I would say you would notice it, but it wouldn't be like being in a fog here on Earth. It would be more of a fine mist than anything. But for the most part, when we talk about nebulae in space, you really it is still a vacuum there. It's still the vacuum of space. Even though there may actually be oxygen atoms and stuff floating around in there, it's so thin, it's not going to resist. You're not going to it's not going to resist your movement, and it's not going to kind of impede any travel. And you're definitely not going to be able to breathe in any of the any gases that happen to be there. All right, next up, we're going just next door. We are going to the last object for tonight, which is the famous Horsehead Nebula, right next to Alnitak, just kind of on the other side. That's where we're going next. The Horsehead Nebula is also known as Barnard 33, after the astronomer Barnard, and he cataloged many dark nebulae, kind of like the one we just saw. It was really dark there. The Horsehead is an even more striking example of a dark nebula that has very high contrast with its background. I also think it looks kind of eerie. I think all dark nebulae look sort of eerie and otherworldly. I guess it is sort of otherworldly, but bizarre. Let's put it that way. Um, so anyway, this is again the famous horse head, and you'll see why it does sort of look like a horse's head. This is a fainter object. It's gonna take a little longer to really see the details, obviously, in this one. But here in just a few seconds, I'll take the first shot. Although the first shot may not be immediately super impressive. But there it is. Let's affect the color balance. Try to get it as realistic as possible. Alright, so it is faint. But let's stretch the image. You can kind of start to see that there is something there. We also have this. This is not real, actually. This little smudge. This is another internal reflection off of Alnitak, kind of bouncing off the interior of the telescope. And that's actually causing this smear that is not actually there in space. You could be fooled, but yeah, it's not real. But what we're really looking at is this thing right here, this dark spot. So I'm trying to expose, something that isn't emitting any light, which obviously is kind of tricky to do, to illuminate something that's totally dark. But the scene is being very gently illuminated by this red region here. And this is from ionized hydrogen, again, from red, and almost purely red, so no reflected light really. And this is from another bright star nearby, not Alnitak, but one of its neighbors, which is energizing this sort of wall of gas, very faint gas, much thinner than other areas. And that is sort of in relief, revealing the Horsehead Nebula. Now this is a faint object, and again we're using the color camera, which is not the best at this kind of object, this kind of situation, where you really just have kind of one color, red, and the rest is sort of black and varying degrees of shades of red or gray. So I do actually plan on revisiting this target on a future program with the monochrome camera, which will reveal it in more contrast. But you can definitely tell it is there. You can kind of make out the head a bit. And there's sort of a stem of the neck over there. But let's take a look at a previously taken image. In this next image I took with a filter that only allows that red hydrogen color to come through and nothing else. And that reveals it in far more detail and contrast. But most of you are probably familiar with this object from views from the Hubble Space Telescope there on the right. It's a very famous image from Hubble. But also contrast that to the view in infrared on the left, also from data from Hubble and other telescopes. and see how different they look. You can see how the infrared view kind of pokes through some of those clouds and reveals structures that are almost completely invisible in the visible light. So again, it goes to show that astronomy is done not just with the light that we can see, but with many different wavelengths of light, which can reveal different details, and thus we can learn many different things about it. And especially when we're studying star-forming regions, infrared is a really useful wavelength of light to pierce through a lot of the clouds of gas and dust that obstruct a lot of what we're seeing. Same with radio astronomy; it too can reveal different structures and things that are otherwise completely hidden in visible light pictures that, like the telescope we have here. But of course, if I were to do this program in infrared or radio, that wouldn't be nearly as interesting or be kind of abstract, hard to relate to. So that's why we stick to color images. But that's the Horsehead Nebula. We'll take one last look at the live view. Now that we've got a few exposures in there, it's starting to come through a little better. And I can kind of try to add as much contrast to the image. There we go. There we go. To really reveal that shape. Isn't that eerie? I think it's just downright sinister looking to me. I'm not superstitious or anything, but that's striking. Gives me the heebie-jeebies. But that's where I'm going to wrap up our live deep sky tour tonight. I hope you enjoyed taking this tour with me through Orion. It's just one of my favorite constellations. It's got so much going on in it. I could do another program just all about all the other stuff in that, but I've hit the highlights here. But this time I'm gonna take as many of the questions I can from y'all. So if you submit your questions in the chat, if you're watching this live, moderators are standing by to answer some of them, and I'm gonna answer a few of them that they have forwarded to me. So let's see. Liz Rader Hagler asks. Stardate earlier this week talked about the stars in the Orion Belt and how one of them was actually essentially different than the others. Could you show us those and expand a little bit? Well, I have to confess, I haven't listened to Stardate this week. I'm a little behind on them. But there's three of the belt: Alnitak, Alnilam, and Mintaka. And the middle star, the middle one, is actually about 2,000 light years away, whereas the other two are about 1,400 light years away. So they're actually much closer than the middle star. And the middle star is much brighter and much more massive. It's an O-class star. It's top of the charts. So it's emitting a lot more light. I'm not sure if that's actually what they were referring to on Stardate, but that's off the top of my head what occurs to me. So again, I'll show that wide field picture. So let me drag this arrow around actually. So this star right here, that is the star I'm talking about. It's actually much further away than the one above it and the one below it. So that again, that it would look like a bright dot if I were to show it in the telescope. So I'm not going to do that right now. It would look a lot like Betelgeuse, just like a different color. But yeah, it is an unusual star in that regard. It's not really quite part of the Orion molecular cloud. It just kind of happens to be there. All right, John Cetera asks, do the dust clouds orbit the stars or are just blown away from the star? Referring to Betelgeuse. Little A, little B. So once they are kind of blown off, oftentimes with very high mass stars, there's a lot of heat and radiative pressure from stellar winds pushing the dust out, and so the dust may just completely escape the bounds of the star. But some of the closer to it may be in orbit, and or may not be in a stable orbit, but it will be at least somewhat to an orbit for a while. So that could be partially responsible for why Betelgeuse dimmed last year. All right, so let's see what other questions we've got here. We've got a question from, I'm just going to call you Mega. What is the effective focal ratio of the scope with the reducer? It is f8. It's usually f9. I've just reduced it a little bit. f8. Still want the detail, but yeah, still not super fast by any means, but it's enough for our purposes. Stephen Yanagasawa asks, I assume someone has attempted to calculate mathematically how many stars are going supernova over time in our galaxy. I was wondering how that matches up to observation. That's a really great question. Yes, mathematically, we expect there to be about one or two supernovae per century in the Milky Way galaxy. We have not seen one or two supernovae per century in the galaxy, though. That doesn't mean they don't happen, though, because we're inside the Milky Way. We only really see and appreciate a small fraction of it easily. And it could be that those supernovae are occurring, but they're on the far side of the galaxy, uh, where there's too much stuff in between us and it in order to see it. And it could be that, we missed it because really the era of actually being able to see everything going on in the sky and analyze it and capture supernovae has only been going on since about really the 80s or 90s when it really took off, and we can really be sure we're not missing too much at least. There's always a part of the sky really close to the sun. It's like what's behind the sun. That's really hard to observe. There could be a supernova over there, and we wouldn't know about it for a while. But we would probably detect a remnant once the sun appeared to move away from that patch of the sky. But it's more likely that they're happening. We're just unluckily situated within the Milky Way to appreciate them. So, yeah, that's the current understanding at least, and it's hard to argue against that. It's also really hard to be sure if that figure of 1 to 2 per century is actually right. But yeah, we're overdue. The last really really good one that was in the Milky Way was in the 1600s. I think 1604. One of the moderators can correct me on that. Early 1600s. So it's been a while before there's been a really good one. Barry Allen asks, can you expand on amateur astronomer Jay McNeil's observation or discovery of M78 in 2004? I don't know enough about that, honestly. I would talk about it if I knew enough to say, but unfortunately, I'm not super familiar with that at the moment. Mega also asks, is the image scale being varied at all, and if so, is it digitally or optically? I haven't really varied the image. I'm using digital zoom a little bit. I think on the Orion Nebula, I zoomed in a bit to like 200 or 300%, but for the most part, I'm just leaving the image as it is and only kind of cropping off the edges. But no, for the most part, like the scale you saw for all the nebulae was consistent. I didn't really change it. So the scales between those deep sky objects were all the same. Daniel Hall asks, what advice would you give to an 11-year-old girl who wants to be an astrophysicist? I would recommend first just keep looking up. The best advice I have is to stay curious, because that's really what fuels astronomers. You've got to. There's a lot of hard work if you want to be a professional astrophysicist. It's brutal and it's competitive, but stay curious, keep looking up. You don't necessarily need fancy equipment of your own. Just, get uh, even a pair of binoculars and explore the sky, and then try to read about what you saw, or vice versa. Find something interesting online that you think you might be able to see, and go out and see it for yourself and discover it. I think there's a lot of value in realizing that all the things you see in picture books and in textbooks and things and movies, it's really out there. That's the real universe, and it's an amazing place we live. I'm sure you'll get a lot of advice, study math, computer science, stuff like that. But I think it's even more important to maintain that sense of wonder and curiosity, because that's really what's going to fuel you long term. Um, Another question from Justice asks, "What personal telescope do you recommend to enjoy the Orion Nebula?" By the way, I'm named after Sirius, the right leg of the Orion. Yeah, that's cool. For the Orion Nebula, if you want your own telescope, on the one hand, the Orion Nebula kind of looks good in almost any telescope, so you could get by with almost anything. But if you want a really good view, I recommend like an 8-inch Dobsonian telescope or larger. Generally, when it comes to telescopes, you want to get as big of a telescope, as wide of an aperture as you can afford and carry and will actually use. What that actually is for you, that depends on what your priorities are and what your budget is. But you really can't go wrong with an 8-inch Dobsonian telescope. They're easy to use. They're great value for your money, and they provide really good views too. So that's what I started with something similar. You can find used ones online as well. Actually, buying one new at the moment, I don't know, maybe it's post Christmas, so this could be different. But I know throughout the pandemic, astronomy has been a really popular hobby, and a lot of telescope retailers were selling out of amateur telescopes. So I would actually recommend the used market first. On a website like Cloudy Nights or somewhere like that, somewhere that actually focuses on it. So Cloudy Nights is a good bet. Um, let's see. I think that's about all the time I have for this evening. Thank you all for joining me on this program. It's always a lot of fun doing these. I hope you subscribe to this channel, and so you'll be notified of future live streams. We do plan on doing more in the future, of course. Uh, Take care, everyone, and clear skies.